Welcome to Ask and Learn.
Okay, so we are now being asked to use the methods of example 6 to prove this identity right here. 2 sine inverse of x equals cosine inverse of 1 minus 2x squared is greater than or equal to 0 for all x greater than or equal to 0. So what you could start off with doing this is to let f of x equal 2 sine inverse of x minus cosine inverse 1 of 1 minus 2x squared. And now the best thing to do is to take the derivative. So we're going to take a derivative f prime of x. So the derivative of sine inverse x is 1 over square root of 1 minus x squared, and since 2 is a constant, we can write 2 over the square root of 1 minus x squared. And then the next one is a little bit more complicated. We have to apply the chain rule. So we take the derivative of the inside, which will give us negative 4x. So we're going to write negative 4x times. Then we can apply the chain rule again. So we take the derivative of cosine inverse, which is negative 1 over square root of 1 minus x squared. But instead of x, we're going to put in 1 minus 2x squared. We're going to do negative 1 over the square root of 1 minus 2x squared. And then what we're going to do is we're going to simplify. We're going to do a little simplification. So we're going to still have 2 over square root of 1 minus x squared. And then this is going to become minus 4x over the square root. And then we're going to expand this. We're going to expand the bottom. We're going to expand 1 minus 2x squared. So it's going to be 1 minus 1 plus 2x. We're going to get 4x to the fourth. We're going to bring this over. And then since 2x, we're going to get 4 minus 4x squared. And this is our formula. So we're going to go to the next page for more space. And then we can further simplify this by, and the reminder, this is f prime of x. So this is the derivative. And we're going to do minus 4x over, let's see, we have 1s are going to cancel, and it's just going to be 4x4 minus 4x squared. So we're just going to be left with the square root of negative 4x to the fourth plus 4x squared. Plus 4x squared. And then if you look at this, we can actually factor out a 4x squared. So we can rewrite this as f prime of x this is going to be written as minus 4x over the square root of 4x squared times 1 minus x squared. You can see if that's the same statement. And then you can actually bring out this 4x squared. So you can bring this out because the square root of 4 is 2 and the square root of x squared is x. But be careful when you pull out if you pull out like a variable out of a square root, you have to put it in the absolute value symbol. But since we are dealing with x positives, because we're told for x positive numbers, so in any number greater than 0 in an absolute value function is the function itself. So we're just going to actually cancel. So we're going to cancel 2. This is going to become 2. And the x's are going to cancel. So then we are going to actually now have f prime of x equal 2 over the square root of 1 minus x squared minus 2 over the square root of 1 minus x squared as well. And we know that this is equal to 0. And we're going to move to the next page. There is actually a theorem in this chapter. This is called Theorem 5. You could refer to this. And Theorem 5 basically states that if f prime of x, if f prime of x is equal to 0, then f of x is equal to c. And that makes sense, because if you have a derivative that's equal to 0, the only way you can have the derivative equal to 0 if c is a constant. So now that we know that f of x is equal to c, we're going to actually do one more step. We're going to actually apply f of 0 to our function, which will give us 2 sine inverse of 0 minus cosine inverse of 1 minus 0, which is also 0. And this is all equal to c because f of x is equal to c. So this is going to give you 0. This is also going to give you 0. So then we're left with c is equal to 0. Now we know the actual value of c, because c is a constant. I forgot to mention that. So c is a constant. So now that we know the actual number, we know that c is constant. So we're going to move to the next page. We can rewrite the function 2 sine inverse 1 of x minus cosine inverse of 1 minus 2x squared is equal to c, but since c is 0, we can just write 0. And now all we do is add cosine inverse to the next side. And we have now successfully proven our statement. And this is the statement we were looking for. If you remember, we were asked to prove this identity. 2 sine inverse of x equals cosine inverse of 1 minus 2x squared for all x greater than 0. And we can see we have done that.